Hello boys and girls, guys and gals. This is matrix number 3 video. This one is on scalar multiplication. Ask anybody that was in Algebra 2 last year, they will tell you this is the easy multiplication. So video 4 will be the slightly more complicated multiplication of matrices. So let's move on to a first example, which actually is not about multiplication, but instead I want to carry on one example from the last video on solving equations with matrices by showing this one example here. So I've got these two matrices, and I want to solve for all my missing variables. I have an x, a y, a z, an x, a y, an x, a z. So I need to solve for x, y, and z. Well, how do I do that? Well, we got to look at the equations here in each part of each matrix. And so what I see right away is in the top right, I have y minus 3 equals 18. So that one's pretty easy to solve. Add 3 to both sides, y is just going to be 21. So now I can replace all my y's with 21. And I'll do that in a different color. So now I'm down to just 2 letters to solve for, x and z. So what I see right here is in the top left, x plus 21 equals 26. That one's not so bad either. So x plus 21 equals 26. So I solve that. From both sides, subtract 21. X is just 5. So I'm going to replace all my x's with 5's. And here I go. And that matrix right there, and then this one right here, and then this one right here. That was 2x. Now it's just 10, obviously, because 2 times 5. So now I've got to solve for z. I can solve for it here with my bottom left or bottom right. I'm going to go bottom left. It looks a little bit easier. So here we go. I know then that 3z plus 2 equals 5, which means from both sides subtract 2, 3z equals 3. Divide both sides by 3, z is just going to be 1. So I can replace both these z's with 1. Since that was 3z, now it's 3 times 1, 3. And this one over here was just z. So let's look at the matrix again for both these matrices. 5 plus 21 is 26. Check. Sorry, I can't control phone calls now, can I? Anyways, 5 plus 21 is 26. 21 minus 3 is 18. Check. 3 plus 2 is 5. Check. 21 minus 10, 11. Minus 3 is 8. Check. So I found the x, y, and z that make these matrices equal. So there's the example is finished. So now on to the actual lesson, scalar multiplication. So here I have a matrix A. It's a 3 by 3, 3 rows, 3 columns. What I want is 5a. This is what's called scalar multiplication. 5a, there's no sign, so that's multiplication. So this is multiplying by a scale of 5 because of that 5 right here. So it's just like distribution. It's actually the exact same thing as distribution. I have a hard time making eyes with this app. Sorry about that. But anyways, I'm going to multiply everything in this matrix by 5. That's all you have to do. It's really that easy. So I'm going to make this matrix in this dark blue color now. Can you believe there's no black on this app? It's a very dark blue, but no black. I can't believe that. And no, they're not the same thing. Okay, anyways. Top left, row 1, column 1, times 5 is negative 10. Next one going down, 2 times 5 is 10. Next one, negative 3 times 5 is negative 15. Going up in the middle, 1/2 times 5 is 2.5. Going down, 0 times 5, still 0. Bottom middle, 1 times 5, still 5. Top left, 6 times 5, 30. Right middle, 9 times 5, 45. And then bottom right, 3 times 5, 15. That's all I did. Basically just distribution of that 5. So if you see a number in front of the matrix, then everything in that matrix just multiplies by that number. Let's go on to a similar example with a couple more steps. So here I have two matrices. I have A, a 2 by 2, and B, a 2 by 2. What I want is the answer to this, 2A minus 4B. Example trace, example 3. So what I'm going to do here is just follow order of operations and do 2 times A. I'm going to basically double A, and then take B times 4, then subtract this from what that is. So you got to follow your order of operations. So let's do each one of those first. So 2A just becomes 14, 6, negative 4, 2, right? Just doubled everything up here. So then the 4B is everything in B times 4. So negative 4, 16, going bottom top right, 20, and bottom right, 40. Don't forget minus sign, so minus sign right there. So when I put these together, my final answer, so top left, 14 minus negative 4, so 14 plus 4, 18. Negative 4 minus 16, negative 20. Top left, 6 minus 20, that's negative 14. And 2 minus 40, negative 38. So that's all you got to do. So apply order of operations, multiply first, then add or subtract, and this is what you're left with. This matrix right there. There's one more type of problem you might see with this, and it's going to be an equation, and this time the answer is an entire matrix, not just one part of a matrix. It will look something like this. So final example, this equation here. So 2 times x. Now x being a capital letter here, this stands for a matrix. Don't forget that. Okay? So 2 times some unknown matrix minus this matrix, 7, 1, 3, this 3 by 1, equals this 13, 11, 10 matrix. So like any other equation, you're going to treat this just like this equation. If this was your equation right here, you would add 7 first, and then you would divide by 2. I'm going to do the same thing over here. So I'm going to add this 713 to both sides to get the 2x by itself. So what I have then is 2 times some matrix equals, so add matrices, just put them together, 13 plus 7, 20, 11 plus 1, 12, and 10 plus 3, 13. Now I have this. So what I'm going to do now to cancel out the 2x, I'm not going to actually divide by 2. Think of it more as multiplying by 1/2. So to both sides, I'm going to multiply by 1/2. This will cancel out the 2. It's reciprocal. And then this 1/2 right here, that is my scale. So everything here gets multiplied by 1/2. So my final answer is 10, 20 times 1/2, 6, 12 times 1/2, and 6.5, 13 times 1/2. This is my answer. So, I mean, yeah, I divide them all by 2, but there really is no matrix division. It doesn't really exist in the world of matrices division, so we think of it as multiplication of 1/2. So that's your answer, and that's the last example in this video. Make sure you go to matrix 4 next, and I'll see you in class. Adios.